Hello everyone, how are you all? Voice is coming clear from my end?
Yes, sir. How are you?
Yeah, I'm fine. Thanks for asking. Yeah, let's begin today's class. Sorry for making you wait 5 extra minutes, okay? Okay, yeah, we will be taking problems today on stacks. Okay, let me share my screen. Able to see my screen, everyone? Able to see my screen, everyone?
Yes, sir.
Okay.
Yes, sir.
The first problem that we will take is balanced parenthesis. Let's say I have a sequence of opening and closing brackets. Okay, sequence of opening and closing brackets. I have to check whether the entire sequence is balanced or not. How it will be balanced? Okay, so let's say I have only two parentheses. Corresponding to this opening bracket, I have a closing bracket. Okay, this opening bracket will be balanced by this closing bracket. So I have to check if suppose a sequence of opening closing brackets are given like this. Okay, so whether this is balanced or not. What I said, an opening bracket is balanced by a closing bracket, but keep one thing in mind, not more than one. Only one opening bracket can be balanced by one closing bracket. Just for taking this example, this is an opening bracket. Immediate towards its right, there is a closing bracket. Okay, just towards the right of this opening bracket, there is a closing bracket. So this opening bracket will be closed by this opening bracket. Okay, we are left after this opening bracket is being balanced by this closing bracket, we are left with something like this. This opening bracket, this closing bracket, this opening bracket, and this closing brackets. These two, this opening has been balanced by this closing bracket. Now we are left with these four. Now it is easy to observe. This opening bracket will be balanced by this closing bracket, and the next opening bracket will be balanced by this closing bracket. So what we have to see, corresponding to every opening bracket, is there any closing bracket for balancing it? What is the condition required? Towards the right of an opening bracket, there must be a closing bracket. Okay, it is not the case that again, if a sequence starts with a closing bracket and then an opening bracket comes, this opening will be balanced by this. This is not the case. For an opening bracket to be balanced by a closing bracket has to write towards the right of the opening bracket. Okay, and once this closing bracket balances this opening bracket, it cannot balance any other opening bracket. That's all. Understood the problem? Tell me that first. Hello. What are the conditions? What are the conditions for getting balanced? For an opening bracket to be balanced, one closing bracket has to be towards its right. Okay, it cannot be towards its left like this. It cannot be. It cannot be this case. Next, one opening bracket can be balanced by only one closing bracket. It is not the case that single closing bracket can balance multiple opening brackets. Moreover, another condition, the immediate closing bracket towards this opening bracket will be balancing it. Okay, this opening bracket got balanced by this closing bracket and not this closing bracket, just towards the right. Immediately what is towards the right, that we have to see. Okay, now yeah, think of it, how will you solve? Tell me, is there any doubt regarding the question? Tell me that first.
Sir, in the one side, one closing bracket, there can be two closing brackets after one.
Any sequence can be there.
Means one closing bracket, then again one open and closing bracket, the whole in a one closing bracket.
Sorry, see something like this. Opening bracket, then a closing bracket, then
Then again open outside.
okay, then
Close it.
okay, close it, then
Close the both in one bracket.
yeah, it can be there. Any sequence can be there. Any sequence of opening and closing bracket can be there.
Okay, sir.
Okay, who will do this problem? Okay, think of this. Tell me first, have you understood the problem? Trupti, your voice is not coming. If you are trying to say something. Yeah, Mahesh, what is the issue? Okay, see, there will be a sequence of opening and closing bracket. Tell me, who are having doubt, what is the meaning of the question? There will be sequence of opening and closing brackets, something like this. Okay, sequence, any sequence can be there. Any number of opening and closing brackets can be there. I need to see whether this sequence of opening and closing brackets is balanced or not. How they are balanced? Okay, there is an opening bracket. It can be balanced by a closing bracket. Okay, so I have to search in the sequence whether all opening brackets have a corresponding balancing closing bracket or not. Okay, suppose that this is an opening bracket, it will be balanced by immediately occurring closing bracket. This cannot be balanced by this closing bracket. Another rule. Okay, next what will happen? Next, what else I have said for the question? Opening bracket can be balanced by a closing bracket that lies towards its right. If it is lying towards its left, it is not the case that this is balanced by this. Okay, this is the question. Now check whether the entire sequence is balanced or not. That is corresponding to each of the opening bracket. Do we have a balancing closing bracket? This is what we want to check. Okay, all of you understood this problem? Tell me that. Please tell me, else how can I understand? So all of you understood. Shall I take that? No responses from your end. What shall I assume? Tell me that first.
Yes, sir, it's understand.
Okay, yeah. Think of the problem. Try solving it. Take 2 minutes, 3 minutes to solve it. Come up with an approach. Then I will tell you how to solve this problem.
Kanu,
Anyone got any answer? Anyone tried to get any solution? How will you solve it?
सर बैलेंस करना नहीं जम रहा, बाकी किया हूँ
बाकी क्या किए हो?
सर। मैंने अगर ओपन पेरेंथेसिस है तो मैंने 0 प्रिंट किया हो, अगर क्लोज है तो 1 प्रिंट किया हो।
प्रिंट तो नहीं, बताना है कि बैलेंस्ड है या नहीं, दिस इज रिक्वायर्ड। प्रिंट तो कुछ भी कर सकते हो, राइट?
पहले एक ओपन एम्प्टी स्टैक डिफाइन करेंगे।
ओके,
इसमें तीनों जो ब्रैकेट्स है पैरेंथेसिस है उनको एज ए कैरेक्टर डिफाइन करना पड़ेगा।
ओके,
अगर कंडीशन में वो दोनों आ रहा है तो वो उसको अपेंड करेगा स्टैक में,
ओके,
और अगर नहीं आ रहा है दोनों इफ कंडीशन लगा के चेक करेंगे, अगर नहीं आता है तो वो उसको रिटर्न करेगा एज इट इज।
Okay. Okay, let's see how to solve this problem. Let's see. See here. Let's say this is my sequence. Okay. Okay. Let's start iterating from the first bracket. Okay. From the first bracket. Okay. I am at the first bracket. Let me take that. This is an opening bracket. Let me take that. Taken. Now move forward. This is the second bracket. Let me take that also. This is the third bracket. Okay. Coming towards the on the third character. This is the third bracket. Let me take that also. Okay. One by one, let's pile up. One by one, let's pile up. First, I have gathered it. Then I will gather this. Then I will be gathering this. Okay. Now see. Next character. Next bracket is a closing one. Can I say that this will be if I have arrived on a closing bracket, this will be balanced. Can I say that? Whenever as opening bracket comes across and immediate closing bracket towards its right, that opening bracket will be balanced, right? So I can say that, okay, now I have arrived on what? I have arrived on a closing bracket. So the last opening bracket that I have got will be balanced. Can I say that? This is the rule, right? Okay, now. So I am left with two opening brackets now. Okay, now. Next bracket is also what? Next bracket is also a closing bracket. So can I say, since the next character is a closing bracket, this opening bracket that I have will be balanced by this? Will be balanced by this? Can I say this? Can I say this? I am getting these two brackets to be balanced. Now after balancing the third closing bracket, I am again getting a closing bracket. So what I will do, I will balance the most recent opening bracket that I have with that of the closing bracket that I am right now getting. Okay, now, so this one is also balanced. I am left with now only one opening bracket. I am left with only one opening bracket now. Let's check the last. What is the last bracket I have? That is again a closing bracket. So now I am getting a closing bracket, and this will again balance this one. So in what sequence we are balancing? In what sequence we are balancing our opening brackets? From last to the first. Can I say that? First, this one will be balanced by this. Then this one will be balanced by this. Then this one will be balanced by this. Getting it? From the last opening bracket to the first opening bracket. This is my sequence of balancing of opening brackets with respective closing brackets. So what I can do is that once I start iterating over this sequence, if I am getting an opening bracket, let me define a stack for that. Okay. Let's start from here. Getting first, what is the first character? Opening bracket. Push it inside the stack. What is the next character? Again, an opening bracket. Push it inside the stack. What is the next character? Again, an opening bracket. Push it inside the stack. Done. Now, what is the next character? Closing bracket. So I have one. So this closing bracket should have balanced the most the just recent opening bracket, right? The just recent opening bracket will be balanced by this closing bracket. So what I can simply say, okay, this can be balanced. The most recent that I have got is stored at the top of my stack. This can be balanced by the opening bracket that I am getting now. Okay, done. How my stack is looking like now? 2 opening brackets. It will contain 2 opening brackets.
इसको pop कर लेंगे क्या?
Yeah, we will pop it up. This is balanced. This is balanced. We'll pop it out. Now next I am on my next. Now next I am on again a closing bracket. So the most recent opening bracket that I have is stored at the top of my stack. At the top of my stack. Now see, this bracket can store it, can balance this. So what I can do, again pop this out. Again pop this out. My stack reduces to having only a single opening bracket. Now again, the last one is what? A closing bracket. The most recent opening bracket that I have is stored at the top of the stack, pop it out. And at the end, I am getting an empty stack. I am getting an empty stack. So I can say, if empty stack I am getting, I can say that all the opening brackets that I have been balanced. Have been balanced. What I have done, whatever opening brackets I am getting, one by one, push them into the stack. One by one, push them into the stack. Whichever is stored at the top, once you are getting a closing bracket, pop that out. Carry on the process till the last character of my given sequence. If the entire string, if the entire stack becomes empty, we can say that, okay, the sequence that has been given is balanced. Okay, now one thing, let's suppose sequence like this comes. Are this balanced? Is this a balanced sequence?
No.
No, sir.
Why? Why? Is this a balanced sequence? Why?
Because
The open is missing.
the extra more closing bracket is there.
Yes. An extra closing bracket is there. This one, this opening will be balanced by this closing bracket. But what this one will be, what this particular closing bracket will balance? Nothing, right? No extra opening bracket is here towards its left. So it has nothing to balance. So hence such kind of sequence is unbalanced. Such kind of sequence is unbalanced. Now again see another thing. Is this a balanced sequence? Is this a balanced sequence?
No.
Why?
No, sir.
Why?
Sir, first
Last
one
two.
is
Let's say,
balance.
okay, let's say something like this. This is a sequence. Is this balanced?
No.
Why?
First and last was balanced. Middle was
Okay,
unbalanced.
this and this can be balanced, right? This and this can be balanced. This and this can be balanced. But what about this? This is left. This closing bracket can balance no opening bracket. Hence it is left. So what I can say, a strict condition I have, whenever I am encountering, whenever I'm encountering a closing bracket, there should be at least one element inside my stack. Am I correct? Am I correct?
Yes.
Sir, repeat again.
Okay, yeah. Let me show you. Let me show you what we will do. See here. What was my example? This, right? If this is my example, let's see. Okay, start building the stack. This is my first opening bracket, push it into the stack. Done. Next, closing bracket, pop it out. Now the stack is empty, correct? Till when I'm coming to this position, stack is becoming empty. Now go to the next character. This has towards its left, no opening bracket is there such that this closing bracket will be balancing something. Till here, is it clear? How will you detect that? whenever I am having a closing bracket, if I get a condition that, okay, this entire stack is empty, I can say that, okay, this particular closing bracket can balance no opening bracket. This particular closing bracket can balance no closing bracket. What is the condition for that? How will we check? If the stack is empty, we can, and if I'm getting a closing bracket, I will simply say, okay, if such kind of condition is occurring, this particular closing bracket can balance no opening bracket. This is the condition. Okay. If such of the condition is occurring, I can say that, okay, directly return false from there. Directly returns false from there. Okay. Now let's try coding this. How will we manage entire balancing in our code? Okay. So let me comment all of these things out. Okay, yeah. Let me copy it. Okay. Let me have the parenthesis sequence. Okay. Let me have it. And let us take that in the form of a string. Okay. Just take that in the form of a string. Fine. Let me define the stack here. Okay. Now, how will I code it? Let's iterate over each character of my string one by one. For I in a range length of parenthesis. Can I do this? Can I do this? Okay, fine. Now see. If, what will I do? If parenthesis of I, how will I check? How will I check? Something like this, can I do?
equals to opening bracket.
Something like this. If parenthesis of I equal to the opening brackets. Will this work? Tell me.
Yes.
Sure. Okay.
So,
Yeah,
but
let's-
there should be a balanced closing bracket.
First, what I will do, if I come across something that is a opening bracket, what I will do,
Stack में उसको push करेंगे.
I will call the push function. Okay, push. What you want to push? Tell me the index of it or the character itself. What you want to push?
Character.
Push what? Push inside the stack. Okay, now let's say for this we don't define any kind of max size. Not required for this problem. Okay. Okay, now just append and we can return as from here. Stack, inside the stack, what do you want to push? Character. Done. Okay. Now else, if it is not a opening bracket, can I say definitely it will be a closing bracket?
Yes.
Can I say that? How many of
Yes.
you agree? It is
No,
made up
no,
of
no.
only opening and closing brackets, right? The entire sequence of parentheses is made up of only opening and closing brackets. If it is an opening bracket, I will check. I will push it inside the stack. But if it is not this, can I say that definitely it will be a closing bracket?
So दूसरे टाइप का भी तो हो सकता है ना.
अभी हम लोग कौन सा टाइप देखते हैं? सिंपल वाला.
अच्छा सिंपल
ठीक है.
ठीक है फिर तो वो डेफिनेटली क्लोजिंग ब्रैकेट होगा.
What it will be? This will be definitely a closing bracket. So what I can do? Okay, before, okay, if it is a closing bracket, what I can say? What I can say? First, I have to check, right? If the length of my stack is empty or not. Length of the stack, if it is 0, if this is empty, If this is empty, what I will do? Return directly false, return false from here. Else nothing else I have to do, just return false, because at least one closing bracket is definitely there that cannot balance anything. So I can say, okay, the entire sequence is unbalanced. If this is not the case, what I can do? Call pop on the stack. Can I do this?
Yes.
Okay, done. At the end, what will I do? At the end, what will I do? Okay, let's do one thing. Let's keep entire of this code inside a separate function called balanced parenthesis. Okay, and that will take my stack. Okay, and as well as the parenthesis. Okay, let's keep everything here. Okay, now I've popped. Now at the end, what I have to check? See, another condition that probably we have missed. What if we have some sequences like this? Is it balanced?
No.
Is it balanced? Why? This can be balanced by this, but these two opening brackets are not balanced. Am I correct? Am I correct?
Yes.
So how the stack will be looking like? First, opening bracket, push it inside the stack. Now, closing bracket, push it inside the stack. Sorry, opening bracket, again push it inside the stack. Again, opening bracket, push it inside the stack. Done. I am getting now, in my last character of my sequence, a closing bracket, pop it. After all kind of operation, entire string now has gone over. I am seeing that my stack is not empty. Am I correct? Stack is not empty. So I have some opening brackets that cannot be balanced. So what we will do? After doing all operation, after running the entire loop, what we will do? Okay, just let me do one thing. Okay. What we will do? We will check if length of the stack, is empty, stack is entirely empty, that is length of the stack is 0, return true. That means all things are balanced. Else return false. If at least there is one element that is left inside the stack, do what? Return false. Can we do it?
Yes.
Okay. Let's update our stack after the push operation. Okay. Now let's try. Okay. Print, do what? Let's call the balanced parenthesis. Okay. Call the balanced parenthesis. And yeah, what we have to pass? Our stack as well as the input parenthesis sequence. Done. This part is done. Let me start the terminal and see whether. Okay, what parenthesis you want to give? What parenthesis you want to take as the example? Give any example, someone? Okay, let's take this. Coming false. Am I getting the correct answer for this? How is it looking like? Okay, what will happen? See, start from the first character. Push it inside the stack. Opening, push. Again, opening, push it inside the stack. Now next, closing. Pop this out. Pop this out. Stack changes to only one single opening bracket. Now next, again a opening bracket, right? Push it inside the stack. Now next, again a closing bracket. Pop the top of the stack. What will be, how the stack is looking like now? Single opening bracket. Okay, now again, see, what is it? Closing bracket. Pop the top of the stack. Only single element, that will be the top itself. Pop it. How the stack is looking like now? Empty. Fine. Again, what is it? Opening bracket. Push it inside the stack. So that's why we have kept the last condition. After doing all operation, after all operations are done, if the length of the stack is 0, entire stack is empty, then only we will return true. Else we will return false, as in the case here. Length is 1, that is 1 bracket is unbalanced. So what we have done? Returned false, and that's why we are getting the result as false. Why false? Because this is as a whole is unbalanced. Let's check for a some balanced cases. Okay. Coming true as a whole. What we have done? How my sequence is? Okay, see. Initially the stack is empty, opening bracket, push it into the stack. Now next closing, pop this out. Stack is now empty. Opening bracket, push it inside the stack. Again, opening bracket, push it inside the stack. Next, closing bracket, pop the top. Again, closing bracket, pop the top. At the end, it is becoming empty. After all operations, stack is empty. So this will return true from here. Understandable what we have done? Tell me. Understandable or not? Tell me that. All of you, any problem regarding this problem? Any doubt? Anything you have, you can ask. Okay, let me walk through the code also with this example. Initially the stack is empty. Okay. Okay. Receive the stack and parenthesis. Parenthesis is this. Stack is this. Okay. For I in range, length of parenthesis. So initially I will be pointing at index 0. So okay, now start. It will come inside the loop. If parenthesis of I equal to this. Is it true? Parenthesis of I. The 0th character of the string is equal to opening bracket. Is it true? What will happen? Stack dot push. Stack dot push. This character has been pushed. Okay. If condition was true, else will be skipped. Entire else will be skipped. It will go back to the loop. It will go back to the loop. I comes second character. I comes to the second character. Now see. Parenthesis of I equal to opening character, opening bracket. Is it true? I is here. I is here. Is it true? Parenthesis of I, pair of I is equal to opening bracket. False. So it will come inside the else condition. Now it will see length of stack. Length of stack is 0. Is it true? Length of stack, is it 0? False. Why? Because we have one opening bracket inside our stack. So it will come inside the else condition. Okay. stack is equal to pop dot stack. That means do what? Pop whatever is the top of stack, pop that and update the stack Done. Go back to the loop. I comes here. Again, see. Check the if condition. Par of I equal to opening bracket, true or false? True. Do what? Push opening bracket into the stack. Done. Okay. If condition was true, entire else will be skipped. It will go back to the ith loop. I comes here. Okay. Parenthesis of I. Again check. Parenthesis of I. Par of I equal to opening bracket. True. Push opening bracket into the stack. Done. Okay, fine. It will, if condition was true, again else will be skipped. It will go back to the ith loop. Fine. I comes here. I increases by 1. I will be pointing to the next character. Fine. Now what will happen? Again check this condition. Par of I equal to opening bracket. Is it true? Par of I equal to opening bracket. Is it true? False. So it will come inside the else condition. Again check. Length of stack. Is it 0? Inside the else condition, this if condition. What is coming? If length of stack is 0, false. So it will come inside the else condition. Do what? Pop the stack. Pop the top of the stack. How the stack will be looking like? It will have now only one opening bracket. Fine. This is done. It will go back to the loop. I points to the last character. Again check. If condition. Par of I equal to opening bracket. False. Do what? Skip the if condition. Come inside the else. Again inside the else condition. Check the if. If length of stack is 0, is it true? Length of the stack is 0? No. Length is 1. Because we have one opening bracket inside the stack. So this condition is false. Skip this. Come inside the else condition. Stack dot pop. Pop the stack. Remove the opening, the top of the stack. Now the stack has become empty. Done. It will go back to the loop. All value of I was already at the last index. It will go out of the loop. That means the loop will terminate here. Now it will check. Length of stack, is it 0? Length of stack, is it 0? Yes. Do what? Return true from here. Done. Any doubt you're having?
So please repeat it again. Actually, your voice was gone in between.
Is it? All of you got the voice or the voice was gone? All of you got?
ऊपर में भी फंक्शन डिफाइन करना पड़ेगा पुश और पॉप के लिए.
हाँ पूरा है ना, डिफाइन किया हुआ है. पुश पॉप दोनों देखो किया हुआ है यहाँ पे. Okay, I will be repeating, don't worry. Fine. Let me take some other example, something like this. Okay, fine. With this example. Okay. Initially the stack is empty, right? Parenthesis is this, par is this, par variable is this. I starts from the first character or the 0th index. Okay. For I in range, length of par. Okay. Fine. I is initially at the 0th index. Length of par is 5. Done. Come inside the loop. If par of I equal to opening bracket, is it true? Is it true? Par of I. What is par of I? This opening bracket. So is par of I equal to the opening bracket? True. So what will happen? Push inside the stack, this opening bracket. Push inside the stack, this opening bracket. Done. Pushed it. If condition was true, else will be skipped. And we will go back to the loop. I now points at the first character. Okay. See this, if this push pop function, I have used the same that we have defined yesterday. They are same. Push pop. I am using them only. After pushing or after popping out an element or pushing an element. Okay. This will return the stack. So I have to store it somewhere. So what I am doing, passing the same stack, okay, and whatever will be returned will be stored in the stack variable only. What I am doing? Push. So inside the push function, I have the stack as well as element T. Okay. Once inside the stack, once inside the stack, the element T is pushed, it will be returning. Okay. It will be returning at this position. And where I will be storing that, whatever variable I was using, that variable will be storing the updated version. Will be storing the updated version. Okay. Don't confuse with this. Now see what will be happening. Pushed it, fine. Opening bracket was there, pushed it. Now I points the second character. Again, if pair of I equal to opening bracket, true or false? Pair
True,
of
sir.
I. So what will happen? Push inside the stack, this opening bracket, pushed it, done. Okay, now it will, if condition were executed, else entirely will be skipped. It will go back to the loop. I increases by 1. Okay. I points to the closing bracket, right? Now see, pair of I equal to opening bracket, true or false? True or false?
False.
So it will come inside the else condition. Okay. Inside else, what is there? If length of stack equals to 0, is it true? What is my length
No.
of stack? It is 2, right? Right now the
2.
length is 2. So this condition will be skipped. This is false. Else we will come inside the else. Pop stack. Pop the stack. That means pop the top of the stack. Now the stack looks like this. Now the stack looks like this. Okay, else condition executed. Go back to the loop. I increases by 1. I increases by 1. Okay. Now again see. If pair of I equal to opening bracket, true or false? True or false? I is pointing here at the second last character. Pair of I equal to
False.
opening bracket, false, come inside else. Inside else, check the if condition. Length of stack is 0. Length of stack is 0. No. Why? Because it is 1. 1 opening
Yes.
bracket is there. So do what? If condition is false, skip it.
Pop
Come
the
inside
stack.
the else. Come inside the else. Pop the stack. Popped it out. Now the stack will be looking like this. Done. It will go back to the loop. Again, I will be increased by 1. I will be pointing at the last parenthesis or last closing bracket. Again, if pair of I, is it true? If pair of I equal to opening bracket, is it true? False.
No.
So come inside the else condition. Inside else, if length of stack is 0, is it true?
Yes.
Yes, it is true. Now length of stack is 0, right? So do what? Return false from here. So this will be returned false here. And finally, we are able to print, if this is my example, let's see. This is my example. I will be able to get false as my result. Getting it? What would happen?
Yes, sir. Got it. Yes, sir.
All clear? Tell me.
Yes, sir.
Okay. One thing note. Once a return statement comes, okay, once a return statement executes, your entire function call ends there. Once you say return, that means the entire function call will be stopped, and whatever value you have returned, mentioned in the return statement, that will be returned from wherever it is called. Don't think that once the return statement has arrived, the next line will be executed. No. If the return statement is executing, entire function calling will be stopped, and from that position, whatever value is mentioned on the return line, that will be returned to wherever it is called. All of you will keep that in mind.
सर ऊपर के दोनों फंक्शन दिखाइए ना.
Okay, yeah, see. Just similar to yesterday, whatever we have discussed in pop, push and pop. See here. This is the push, and this is the pop function. So at the end of doing if I'm performing any operation, I am returning the stack itself. So I have to store it somewhere. So where I am storing? I am updating this variable only. I am updating this variable. This is the push function. Stack is equal to stack push. Okay. If the stack is empty and I call upon this stack that push this opening bracket, what will be happen? What will happen? Stack is passed here. Stack is passed here. Stack dot append d. That means inside the stack, I will be appending this character, and that will be returned here. That will be returned here. Where from wherever it is called, that will be returned. And stack variable was initially pointing here. Now this is getting returned. Stack variable will be pointing here. Such kind of technique we have used here. Okay. We are updating again and again the stack variable. That's all. Can you do it now? Tell me. Can you do it? All of you?
Yes, sir.
All clear or any doubt you are having? Tell me that. Okay, let's come to the time complexity. Okay, see, again, similar kind of complexity calculation we have done. Tell me, inside the stack, how many times, maximum number of times this particular bracket can go? How many times this bracket can go inside the stack? How many times this particular bracket can
Only
go
one.
inside the stack?
Only once.
Maximum is 1, correct or wrong? Maximum is 1.
Yes, sir.
What is the worst case? What is the worst case? What is the worst case? When all are opening brackets, I will be pushing each and every of the character inside the stack, right? Okay, tell me one thing to tell you, one thing that we haven't discussed yet. We push inside the stack, any particular element T. Push operation takes exactly big O of 1 time. Pushing at the top of stack takes big O of 1 time. Similarly, popping out the top element from the stack takes big O of 1 time. Okay. Now see, if this is the case, that all inside my stack, all are what? Opening brackets. What I will do, as per my code, I will push them one by one into the stack, right? If there are n opening brackets inside my sequence or parenthesis sequence, I will be pushing them, each and every of the character inside the stack. Am I correct? Stack will be looking like something like this. And it will go on till n opening brackets. So,
Yes, sir.
okay. How many times? Each of the character I have pushed exactly once, right? No point of popping it out because there are no closing brackets. Done. Pushed it once. What is the time required to push? What is the time required to push? Perform the push operation. Sorry, let's say how many operations are required to do the push? How many operations are required? 1 operation, not more than that. For performing the push operation, we require exactly 1 operation as per our computer standards. So how many times we have performed the push operation? N times, right? There are n opening brackets. I have pushed all of them into the stack. This will be happening if this is my sequence. So how many times I perform this 1 operation? N times. So what is my total number of operations? N into 1. So what is my time complexity? Big O of n. Getting it?
Big O of n.
Getting it? That if the problem is this, you can solve this problem using stacks in big O of n time. Getting it or not? Tell me. Any doubts?
Clear, sir.
Any doubts you are having? Else we will move to the next problem. Okay, let's move to the next problem. Let's say I have a sequence of numbers 1, 5, 4, 3, 2, 1. Let's say something like this. For each of the element that are present inside the sequence, or let's say this is an array of numbers. For each of the element that are present inside my array, I have to find its next greater number, or rather just next greater number. What is just next greater number? For this one, how many greater numbers are there towards its right? Who will tell? How many elements are there which are greater than 1 that lies towards its right? How many numbers are there?
So 4.
5
Four.
is there, 4 is there, 3 is there, 2 is there, right? Just next greater element means which is the immediate greater element towards its right, means just next. So for 1, the just next greater element is 5. Okay. Similarly for 5, which is the just next greater number?
No greater number.
No greater, right? So for 1 it is 5. We can say for 5, if no greater element is there towards its right, we can write -1. Okay, -1 will indicate that no greater element is lying towards the right of 5. Okay, come to 4. Which is the just next greater number? Which is the just
No.
next greater number? No greater number. Okay, let's do
No.
one thing. Let's take another example. This is a very specific example. Okay, that's coming. Let's say 1, 3, 2, 4, 6, 5, 3. Let's say. Okay. So, okay, what is the just next greater number of 1? Who will tell?
3.
For 1, how many are there? Total greater numbers 3, 2, 4, 6, 5, 3. All are there, right? All numbers are greater than 1. Which is the closest? 3. So I will write 3. Which is the closest of 1? 3. And where it is lying? Towards the right of 1. I have to see towards the right of 1. Which one is closest? This 3. So 3 will be the output for this one. Again, let's come to 3. How many greater numbers are there towards the right of 3?
3.
Well,
4,
which one
6,
are they?
5.
4,
4,
6,
6,
5. Which one is the closest?
4.
So just next greater number of 3 is 4. That is towards its right. Now let's come to 2. How many greater numbers are there? 4 greater numbers. 4, 6, 5, 3. Which one is the closest? 4. Which one is the closest? 4. Print it. Fine. Now 4 is coming. How many greater numbers?
2.
How many greater numbers towards the right of 4? 6 and 5. 2. Which one is the closest? 6. Print 6. Again, come to 6. How many greater numbers towards the right of 6?
No greater number.
No greater number. Print -1. How many numbers towards the right of 5 that are greater than it?
Sir,
No
there
greater
is no
number.
greater number.
Print -1. Okay, again. Towards the right of 3, no number is there. So no greater number can be there. Print -1. This will be the output. Think of it. Try solving 2-3 minutes. Then we will take this problem. How will you solve? Okay, come up with a brute force approach. Using loops, how will you solve this? This is your task. I will show you how to use stacks in this problem. Using loops, try solving this problem. How will you do? Using two nested loops. Two nested loops. I think this should be done. I think this part should be done by you. Who are able to solve using loops? How will you solve? Kanu has done it correctly. Very good. Kanu is a good coder, I think. Who has done the solution using loops? Tell me. Apart from Kanu. Okay, Trupti, yours 1 is 2, also good. Yeah, no problem. Trupti also has done it correctly. Anyone else would like to come forward with solution? Who is Spidey, by the way? Okay, yeah, Junaid has also done it correctly. Who else has done it using loops? Who else has done it? Only 3 persons. Who? Trupti, Kanu, and Junaid. Saurabh, Memon, where are you?
ऑपरेटर प्रिंट हो गया सर, बट बाकी नहीं हुआ.
Akhilesh, Anjali. Is it done? Varnik, Deepa, Shazia, Amar. Govardhan Ibrar. Okay, let's see how can we do it using brute force or using two loops. Okay. So this was related to balanced parentheses, right? Balanced parentheses. Done. Let me now comment this out. Now comment this out. What is the next question? Next greater element. Next greater element. Fine. Now see. Let us take an array. Okay, let us take an array. What was the example we have taken? 1, 3, 2, 4, 6, 5, 3. Okay. Now let's run the loop for I in a range. For each of the ith element, I will be checking what is its next greater element for I in a range length of array. Okay. Now how will I have to check all the elements towards its right, correct? So let's define the next element as -1 initially. Okay, that initially I have found no element to be greater than my current element I or my current ith element. So let's run the jth loop, a jth loop that will check all the elements from I plus 1, that is towards its right, to the end of the array, Done. So what conditions I have to check? If array of j is greater than array of I, the first element that I will get towards its right will be my next greater element, right? Will be my next greater element. So I will store inside the next greater array of j. Can I do this? And the first element only has to be considered. No need to see further. Break it from here. And then for each of the element, print what is the next greater element that we are having. Let's try running this. Okay. Let me do one thing. We can do it like this. 3, 4, 4, 6, -1, -1. Have I done it correctly? Is it the supposed answer? 1, 3, 2, 4, 6, 5, 3. Is it the supposed answer? For 1, what is the answer? Next greater element 3. Done. For 3, what is the next greater element? 4. Done. For 2, what is the next greater element? 4. Done. For 4, what is the next greater element? 6. For 6, no next greater element, -1. For 5, no next greater element, -1. For 3, no next greater element, -1. This is my output or not? Am I getting the output? So this is the brute force approach. Okay, what is the expected time complexity of this? Who will tell?
The big O
N
n
square.
square.
N square.
Exactly. This is big O of n square. Shall I have to explain why is it big O of n square? Tell me that.
No, sir.
The time complexity of the brute force approach for this problem is big O of n square. 2 loops are running. In worst case, it will give big O of n square. What will be the worst case? Worst case will be something like this. 1, 1, 1, 1, 1, 1, when all elements will be same. In these conditions, or the entire array is arranged in descending order. These are the cases when you will get worst time complexity. That is big O of n square. I leave this as a task to you. Why in these cases I will be getting big O of n square time complexity. This is your task. You have to report that me on Monday. That's why it will happen. Okay.
क्या एक बार रिपीट करो ना, आवाज अटक गई थी मेरे इसमें.
Achha, see, what is the worst case? When all the elements of array will be same, or the array is arranged in descending order. In these 2 cases, I will be getting the worst time complexity big O of n square. Getting it? Now you have to tell me on Monday why in these cases I will be getting the worst time complexity. Think of it. And those who are not able to come up with a brute force approach, see this code. Simple approach. For each of the ith element, let's say 1, I will run jth loop, and this j will be 1 by 1 iterating over all the elements of my array that is towards the right of ith element. whenever this 3, whenever I am getting any element, immediate element that is greater than 1 towards the right of 1, I will be printing, or inside the next element variable, I will be storing this value and I will be breaking the jth loop there. Now what will be the, whatever the final value of next element will be, I will be printing it there. And by default, I will be keeping it -1. This -1 indicates, okay, till the time I have found any element, I am assuming that no greater element, in worst case, is existing towards the right of any element I. Getting it? This is how the code is working. Tell me that. Is the brute force approach clear? Little bit even. Can you do the brute force approach now? Hello? Hello?
Yes, sir.
Yes, sir.
Sure, brute force can be done by all of you. Can I assume that? Okay, now see, how can we optimize this problem using stacks? How we can optimize this problem using stacks? What was my sequence? 1 3 2 4 6 5 3. 1 3 2 4 6 5 3. Fine. Let's define a stack and let's start iterating from the end of the array, Okay. We can directly say, right, that, okay, towards the right of end element, towards the right of our last element, there is no element. So what I can directly say, whatever may be the array is, the answer for the last element is always -1. Can I say this? Because towards its right, no element is existing. Can I say this? So let's,
Yes.
okay, let's print -1 for the last element, push the 3 inside our stack, This part is done. Okay, fine. Next, come to the 5. Let's come to 5. Okay. How many elements I have inside my stack?
Only one element.
3. So can I say that, okay, whatever element towards the right of 5 are inside the stack? Can I say that? Whatever element is towards the right of 5 is inside the stack. Can I say this?
Yes, sir.
Towards the right of 5, 3 is there, only one element. Whatever it is already pushed inside the stack. Okay, let's search. Let's do one by one. Let's pick up the top element and see whether any of the element inside the stack are greater than 5 or not. Only one element is towards the right of 5. What is it? 3, the top element. Let's pick that up. Top element is greater than 5. True or false? True or false?
False.
So, okay, only one element towards the right of 5, that is inside the stack. Checked it. So I have found that no element towards the right of 5 is greater than it. So what answer should I have for 5? Only one element was there, that is at the top of stack. Checked it, but haven't found it greater than 5. So answer for this 5 is -1 again, no doubt. Now tell me one thing. I have pushed 5. Let's say I have pushed this 5 inside the stack also. Okay. Now again see, 6 is coming. The next element 6 is coming. So okay, whatever elements towards the right of 5, towards the right of 6, sorry, are inside the stack. Can I say this? Can I say this?
Yes, sir.
Yes.
So one by one, do one thing. Let's pop the top element one by one. Let's pop the top element and compare with 6. Compare with 6. This 5, I have popped it out, compared with 6. Okay. And then, is it greater? No. Again, pop the 3. Is it greater than 6? No. Both of the elements are not greater than 6. Let's again push them in the order they are existing. And again, let's say push 6. Let's say push 6. Okay, done. Let's come to 4 now. Let's come to 4. Okay, now whatever elements towards the right of 4 are there, are they inside the stack?
Yes.
So let's check them one by one. Am I correct? Let's check them one by one. Okay, checked 6. Checked 6. First, let's check the 6. Is it greater than 4? 6 is greater than 4. True or false? So tell me, is 6 the first element that is greater than 4? Is it true? Is 6 the first element that is greater than 4? Is it true? So, okay, I have compared 4 with the top element. I have found it to be greater than 4. So, is 1 checking enough for this? Is 1 checking enough for this?
No.
That, okay, 6 I have checked, that is greater than 4. No need to check this. Can I say? No need to check the 5 and 3. Can I say this? What is happening? The most recent element that is greater than 4 is maintained at the top. Correct? Just greater. Immediate element towards the right of 4 that is greater than 4 will be considered. Where is it residing? At the top. No need to see what is kept at the bottom. Can I say this? Can I say this? What is the index of this? What is the index of this? 3 is the last index, 5 is the second last index, and 6 is the third last index. For 4, I have to check 6 first, right? I have to check 6 first. If this 6 is satisfying the condition, I will not check for 5 and 3 anymore. Because I have to print next greater element. That is, among all greater elements that are lying towards the right of 4, I have to print the first element that is greater, that is 6. So do I need to check 3 and 5? The answer is no. Only 6. Once I am getting that, okay, this top element was 6. So I have found that, okay, the top element itself was greater than 4. So no need to check. No need to check the below elements of it. What I can do, I can simply print 6 for this 4 and can push 4 above it. Okay, just let me do it in a better manner. And can simply push 4, okay, inside the stack. Okay, what is the next element? 2. Next element is 2. Okay, fine. Next element is 2. So, okay, for 2, again, the same condition is arising. Top element itself is greater than 4, is greater than 2. The most recent element that I have maintained, that I have got 4, is greater than 2. So, can I say 4 will be the answer for 2 and push 2 similarly inside the stack? Now come 3, come with 3. Two also I have pushed. Come with 3. Okay, is 2 the topmost element of the stack? Is it greater than 3? No. So do what? Pop it. Pop it. Okay, again 4 is greater than 3, right? The most I am building the stack. How? From the last to the first element. Something like this, I am building the stack up. So the most recent element 4, most recent element that will be greater than 3 will be definitely at a higher position than the lastmost element that is greater than 3. So again, I'm getting that up just by one popping out these 2 ones. I am getting this 4 greater than 3. So I can simply say that 4 will be the answer for this 3. And do what? Do what? Let me wipe out a bit first. Push the 3 as it is. Okay, now last element 1 is coming. Just compare the top, that is greater than 3. That is greater than 1. Okay, 3 is greater than 1. Print 3 and push 1. So any observation you are getting? I have built it, my stack, starting from the last element and the most recent element, right? The lowest index is maintained at the top of stack. Am I correct? So before pushing it, I can just simply do some kind of popping out and can check which is the most recent closest index I have as element greater than my element I that I am checking for. Will it work? What do you think? I have got my answer successfully, I guess. I have got my answer successfully. But this is not no greater than, this is no better than the brute force approach. Because I have to again and again pop out the elements and push them back, right? Something like that we were doing here. Okay, yeah, what had happened? Fine, so see one thing. Let's say this is my sequence. Okay, again, start from the back. We can safely say 6 is the last element, cannot have any next greater element. So print -1 for it, push 6 inside the stack. Come to 4. What is at the top of stack, or what is maintained, which is the most recent element inside the stack, such that is greater than 4. 6 itself, the top itself. Okay, so I can write, okay, 6 can be the most next greater element for 4. Push 4 as it is. Okay, now 5 is coming. Okay, now see, which is all the elements inside the stack that I have that are towards the right of 5 are maintained inside the stack, correct? Okay, fine. 4 cannot be next greater element of 5. Am I saying correct? 4 cannot be next greater element of 5. Pop it out. Now the stack is something like this. Now check for 6. 6 is element that is greater than 5. So I have found most recent element that I pushed inside the stack that is greater than 5. Most recent element. Print 6 here. Print 6 for 5. And no need to push 4. No need to push 4 again. Print 5 here. Sorry, push 5 into the stack. Why I have done this? Any idea? Anyone can get? No need to push this 4. Rather push 5. Pop this 4 out. This is smaller than 5. Can I say, since 5 is greater than 4, any element that is lesser than 4, and that is towards the left of 5, will have next greater element 5, not 4. Can I say this? That okay, if some element 1, 3, 2 is there and 5 and 4 both are towards the right of these numbers, 5 is a better answer for all of them rather than 4. Can I say this?
Yes, sir.
5 is a better answer. Why? 5 is greater than 4. No need to check then. No need to check. No need to check for 4 again. Just pop it out from the stack and push 5. Now come to inside 2. Come inside 2. Okay, again, what is the most recent element that you are getting that is greater than 2?
5.
The top element 5. Okay. Print 5 and push 2. Since 2 is smaller than 5, push it as it is. No need to worry upon that. Okay. Push it as it is. Now again, what is coming? 3. Next element is 3. Again, what is the most recent element? What is the most recent element that is greater than 3? Most recent element that is greater than 3 inside the stack.
5.
5. So again, I can say both 3 and 2 is lying towards right of 1. For this one, 3 is a better answer than 2. Can I say this? No need to check for this 2. I can simply pop it out and print 5. Print the top element. First element that I have got inside the stack that is greater than 3. That will be the answer for 3 and push 3. No need to push 2 again. Push 3 inside the stack. Again, check for 1. Check for 1. Last element is 1. What stack I have maintained? What stack I have maintained? 1. So 1 will be checking what is the most recent element? 3. 3 is greater than 1. So print 3 for it. And finally, my stack will be looking something like this. So can you observe one thing? We have maintained increasing order of stack. Have I done that? Ascending order or increasing order of stack? All the stack elements from the top to the bottom is maintained in ascending order. Can I say that? Can I say that? This is the main motto behind the question. When you are to find the next greater element, you have to maintain ascending order of elements inside the stack. Okay, in the stack you have to maintain ascending order of elements from top to bottom. And keep on searching. What I will do, whenever I have maintained my stack, always for any element always the stack will have increasing order or ascending order from top to bottom. Now let's say I have got an element. I have got an element 2. 2 will be now the element for which I will be calculating what is the next greater element. So see, if I enter this 2 inside the stack, is the stack maintained in ascending order? Is it true? Is the maintenance of stack in ascending order will be there if I push 2 inside the stack? True or false? False, right? So how can I maintain the ascending order? I have to find the next greater element, keep on popping all the elements that are greater than or equal to 2, because I have to find the next greater element. So once I have found an element that is greater than 2, stop. Print the top element as the answer of 2 and then push inside the stack the element 2. That's all. Little bit tricky. This problem is little bit tricky. Tell me now what doubts you are having regarding this problem. Tell me what doubts you have regarding this problem. Shall I code it or you can try coding it? Tell me. After the exams, can you have a shot? Can you code it? Yes, let's try the code part also. Okay, then. Brute force approach we have seen. Okay, let's do one thing. Let's copy our push and pop here. Let's copy our push and pop here. Okay, done. Now next, what will happen? Next vector, let's define the method next vector that will accept an array. Okay, that will accept an array. Fine. Let's define our stack here also. Stack here only inside the method. And then let's run over our array for I in the range length of array. Okay, shall I have to run like this? What we did? Let's say 1, 3, 2, 4, 5. This is my array. We were taking the elements in the reverse direction, right? So we have to do what? Let's do one thing. We know that answer for the last element is always -1. Answer for the last element is always -1. Answer for the last element is always -1. So what I have to do? Inside the stack, let's say we will be pushing. Let's keep a separate answer array where we will be storing answers for each and every element. Okay. So the first answer that I will push is -1. That is the result for the last element. Whatever may be the arrays, last element cannot have any next greater element. Okay. So answer, sorry, this is not it. Answer dot append -1. This is what I have done. And yeah, stack is, let's initialize our stack with last element of array. This is what we will do, right? Now, okay, let's run our code. Let's start running our code from length of array -2. It will stop where? It will stop where? At -1. And the number of steps it will take will be -1 because we are traversing in a reverse order. Okay, fine. Now see. What we will do. While whenever I want to check for this element, so what we will do, I will see inside all elements of the stack from top to bottom, which element I am getting that is greater than 4. This is what I will check. So what I will do, while, okay, so let's keep okay, where is my top? Let's define the top function again here. Fine. While what we can do, while length of the stack, while stack is not empty. Okay, yeah, for that let's do one thing. If my stack is empty, what will happen? If my stack is empty initially, if length of my stack is 0, can I say no element inside the stack is there in which I can check for the ith element to be greater than, to be the next greater element for ith element? If this is the case, simply do what? Answer dot append -1. Append inside the answer -1. So yeah, we don't need to do anything here. Especially we can keep our stack also empty as well as our answer array also empty. If the length of the stack initially is empty, do what? Answer dot append stack and answer dot append -1, and inside the stack apply the push function. Apply the push function. What I have to push? Array of I. Okay, array of I. Pushed it. Fine. If this is not the case, so what I can do? I can run a loop while length of the stack is greater than 0, and while the stack is not empty, and rest what condition I have to do? And pop out all the elements from the top of the stack such that they are lesser than or equal to my current ith element. And stack of, top of my stack that I have is lesser than or equal to array of I. Do what? Till the time this is correct, pop. Perform pop operation. Pop stack. Done. Now after this I will again check if length of the stack. So let's keep this after it. Let's keep this after it. No need to keep it before it. If this is the case, do this. Okay. Else, I have found an element at the top of my stack such that at the top of stack I have found an element such that that is greater than array of I. Answer dot append top of array of I. Sorry, not top of array of I, top of stack. And after this, push inside the stack. Array of I. So let's do one thing. Since push operation will always be there. Okay. Let's keep it after any if and else condition. And yeah, let's remove this. Okay. This part is done, I guess. And from here, return the answer. Return the answer, whatever we are getting. Answer array itself. Okay, now let's define an array. 1, 3, 2, 4, 5. Okay, let's define an array and print the next greater element. Next greater function, next greater array that I will be getting once I pass this entire array. Have I got the correct result? See. Have I got the correct result? What should be my answer? 1, 3, 2, 4, 5. -1. this for this 5, for this 4, for this 4, for this 3. Have I got exactly the same in reverse order? Have I got exactly the
Yes,
same
sir.
in reverse order? So I have to do what? Return answer of, how will I reverse? Something like this. Three, four, four, 5 minus 1. Is it correct now? Is it correct? Now let's see
Yes, sir.
what we have done. What we have done, let's see inside our code. What is my array? What was my array that we were taking? 1, 3, 2, 4, 5. Okay. For I in range, length of array minus 1. I is pointing at the last element. Initially, stack is empty. Answer array is also empty. Okay. Answer array is also empty. Fine. Now, okay, let's come inside the loop. While length of stack is greater than 0, is it true? Initially, the stack is empty. Length of stack is greater than 0. Is it true? Is it true? Length of stack is greater than 0. Is it true? False. Top of stack is greater than. Both are false. No top also exists initially because the stack is empty. And length of the stack, this condition is false. So while loop will not run because first condition is false. For running any AND, for in running while loop, both the condition has to be true. If any one of them is false, loop will not execute. Now next, come to the if condition. Length of the stack is 0. Is it true? Length of the stack is 0. Do what? Append inside the answer minus 1. Appended, and else condition will be skipped. Stack is equal to push inside the stack array of 5. What is array of 5? 5. Pushed it finally. Done. Let's go back. Let's go back to the loop. Let's go back to the loop. I goes one step, minus one step. One step back. I will be going one step back. Fine. I is here now. Again, come inside the loop. Come inside the loop. While length of stack is greater than 0. Is it true? Length of stack is greater than 0. True or false? And top of stack is lesser than equal to array of I. Is it true? Array of I is 4. Top of the stack is lesser than 4. Lesser than or equal to 4. Is it true? Top of the stack is 5. Array element is 4. So this condition is false. Loop will not execute. Loop will not execute. Again, see, check this condition. It will come here. If length of stack is 0, length of stack is 0, false. Come inside the else. Answer dot append top of stack. What is the top of stack? 5. Append that inside my answer. Appended it, and stack is equal to stack dot push array of 5. Push this 4 inside the stack. Done. Go back to the ith loop. I goes one step back. I goes one step back. See here. I is 2. I is 2. Now again come inside the while loop. Come inside the while loop. I is at 2. Come inside the while loop. While length of the stack is greater than 0. This condition is true. And top of stack is greater than equal to array of I. Is it true or false? Top of the stack now is 4. It is lesser than equal to array of I. False. 4 is greater than 2. Okay. So this condition is false. This will not execute. Come inside the if condition. Length of the stack is 0. True or false? Length of the stack is 0. True or false? False. We have 2 elements inside our stack. Skip this. Come inside the else. Answer dot append top of stack. Whatever is at the top of the stack, append it inside the answer. And then stack, push inside the stack array of 5. What is it? 2. Pushed it. Done. Go back to the ith loop. Okay. While length of stack is greater than 0. This condition is true. Top of the stack. What is the top now? 2. Top of the stack is lesser than equal to array of 5. True or false? Both are true, right? Both are now true. So stack, pop the stack. Pop this 2 from the stack. How my stack is looking like? 5 and 4. Okay. while. Go back to this while loop. Again, length of the stack is 0. Length of the stack is greater than 0. True. Top of stack lesser than equal to array of I. What is the new top? 4. Is it lesser than equal to array of I? False. So loop terminates here. Loop terminates. Length of the stack is 0. False. Else, come inside the else condition. Answer dot append top of stack. What is top of stack? 4. Append that inside the answer, and into the stack push 3. Push 3. See, all the whatever we have maintained inside the stack till now are in, from top to bottom, they are in ascending order. They are in ascending order. Fine. Now the last element is left 1. Last element is left 1. Okay, 1 is left. It will go back to the loop. While length of stack is greater than 0, true. Top of the stack lesser than equal to array of I. Top is 3. What is array of I? 1. So 1 is lesser than equal to 3. False. This condition will not execute. It will come here if length of stack is 0. False. It will come inside the else condition. Answer dot append top of stack. What is the top? 3. Right now I have inside the top 3. And then stack dot push array of I. Finally 1 will be pushed. It will go back to the loop. I was pointing here. I will go out of my array index. I will go out of my array. This while loop, this for loop terminates. Finally, I return reverse of my answer. Reverse of my answer will look like something like this: 3, 4, 4, 5, 1. Why reverse of the answer? This is the answer of index 4. This is the answer of index 3, index 2, index 1, index 0. So I have to print in reverse order. That's why the reversed copy of this answer array I have returned. Finally, I'm able to print this. Tell me now if you're having any doubt. What we have done. What's the main theory behind it? What's the main theory behind it? If any array of j, I am getting, that is greater than array of j plus 1, let's suppose, or any element that is greater, that is at a greater index than j. So this will not serve as my better answer as compared to this. For any element array of j minus 1 that is lesser than array of j. This is the main intuition behind this question. So for this, you have to maintain strictly increasing stack from top to the bottom. This is the main intuition behind it. We'll explain more in the next class. Okay. Tell me if you are having any doubt regarding the code. We'll discuss the time complexity next class, in the next class. Any doubts, anything? Shall we go ahead with the MCQs? Then we will wrap up for today. Yeah. First question given. Created the attendance also. Those who don't have any doubt can mark your attendance and you can leave. Any doubts you are having? You can ask. Very good night to all of you. All the best for your exams tomorrow. All prepared for tomorrow?
So
Yeah.
actually, I'm not able to pass the attendance, mark the attendance.
Why? Haven't attempted all.
Yes, sir.
And how many MCQs attempted?
So all
Still not? Why? Try once more.
it is showing unable to submit attendance. Session time has expired.
Like, how can that be? Just do one thing. Refresh your page once more.
Okay.
Hello, sir.
Yeah.
Yesterday I was Git problem. Git is not solved for me.
Yet not resolved.
Yes, sir.
Have you tried reinstalling the Net Framework 4.7? Hello.
Hello, sir.
Yeah, tell me.
I changed the voice, sir, and again format the C and again reinstall the OS.
Have you done that?
Yes, sir. But Git is cloned, sir. But it's showing when I am changing the branch, it's saying that repository is not there.
Show me. Let me show me that. What's the
I'm
problem?
sharing the screen.
Okay.
I'm deleting this folder. It's saying like
Not a Git repo. But why are you doing inside desktop? You have to clone the repo, right?
last time also I did like
It's
this.
de-
Okay, sir.
No, you haven't done like this. This is not the This is not the process. Okay, give me the. Is desktop a remote repository? How can that be true, man? Go ahead. This one is the remote repo, Ramanil.
Ramanil.
What is the full name of it?
Ramanil Mopathi.
Rama Anil. Then what I have to write?
Mopathi.
Moparthi
Dash AU26.
dash.
AU26.
Okay, now it is coming, master.
Yes.
Now do the git checkout. Git checkout def. Now it is coming. You have to go inside the repository, na? Then only it will be happening.
Okay, okay, sir.
You were inside the desktop. That's why it was not happening, right?
Okay, sir.
Okay,
Thank
fine. Anything else?
you. No, sir, fine, sir.
Okay, yeah.
हेलो
बोलो.
सर मेरे इसमें पॉप फंक्शन वर्क नहीं कर रहा है
दिखाओ. शेयर स्क्रीन करो. Where is it?
ये पॉप डिफाइन किया है यहाँ पे
Stack is equal to stack.pop. करो वहां पे.
कहाँ पे यहाँ पे
स्टैक को अपडेट भी करना है ना. तुम लोग लगता है आजकल यही करते हो, मेरे कोड के साथ साथ कोड कर लेते हो, इसीलिए कोई आवाज नहीं करता एकदम क्लास के अंदर.
सर मैं तो एमसीक्यू दे नहीं पाया, अटेंडेंस ही नहीं लगेगा, मैं तो इधर प्रॉब्लम हो गया नेट का.
अच्छा कोई नहीं, टिकट ट्रेस कर देना और क्या. हाँ प्रॉब्लम आ रहा है 573. वेयर इज इट दिखाना.
वही सेम
stack.pop stack. कौन सा क्वेश्चन है ये? पैरेंथेसिस का.
पैरेंथेसिस.
अच्छा
ये पहले पुश फंक्शन डिफाइन किया,
ओके
तो ये पॉप फंक्शन डिफाइन किया,
ठीक है.
बट ये वर्क क्यों नहीं कर रहा. अब यही सेम फंक्शन मैंने यहाँ यूज किया है.
अच्छा रुको देख लेने दो.
पॉप फंक्शन के बाद रिटर्न कर.
पॉप फंक्शन दिखाना. रिटर्न हो रहा है ना पॉप में स्टैक.
रिटर्न किया ना स्टैक को.
क्या है
Okay, length of stack is 0, return true, else. What is the issue? Let me see.
और यही सेम ऊपर का पॉप फंक्शन जो है ना नीचे यूज किया हूँ. दूसरे वाले इसमें वहाँ
अरे
work
स्टैक
करो।
डॉट पॉप स्टैक क्यों कर रहे हो? ये तो डिक्लेरेशन ही गलत है।
Stack is अरे sorry।
करो इसको, ये करो, हटाओ यहाँ से। क्या हो रहा है?
मैं बीच में
अब इस हो गया, अब सेव करके रन करो।
हो गया इसमें सेव नहीं करना पड़ता। Stack is equals to proportion।
अब करो।
आ गया।
आ गया, चलो। और कोई प्रॉब्लम, कोई इश्यूज मेरे टीचिंग के साथ तुम लोग को आ रहा है? बुरा लग रहा है पढ़ना, समथिंग लाइक दैट, तो बता सकते हो।
मैं इस वीक का तो कुछ नहीं करूँगा।
सच में?
हाँ क्योंकि मैं खुद भी बहुत कम ध्यान दे पाया। 3
अच्छा,
दिन का आवाज ही बंद थी।
ओके।
अटेंडेंस के लिए आए थे सिर्फ।
अमर बता पाएगा सही से लगता है।
अमर भाई का नेट का इश्यू है।
अमर भी आजकल चुप ही रहता है।
बट
सर
ये
प्रैक्टिस नहीं हो पा
क्या हुआ? ओके,
ये थोड़ा सा क्रिटिकल जा रहा है।
चुप्पी, कुछ बुरा बुरा लग रहा है टीचिंग वगैरह में?
नो सर।
पक्का?
यस सर।
ओके, सही, चलो।
थोड़ा सा लेकिन समझने में डिफिकल्ट जा रहा है।
अभी तो टॉपिक्स ही डिफिकल्ट है, सब कुछ नया देख ही रहे हो शायद पहली बार।
हाँ
यस सर,
recursion
कुछ
नहीं
कुछ
पड़ा।
ऊपर से जा रहा है।
जाएगा ही, ऐसा होता ही है।
वो
पूरा
इसी
टाइम
वजह से
स्पेंड करो, हो जाएगा, इसमें कोई बात नहीं है।
मेन प्रॉब्लम वो भी तो है ना सर, टाइम भी
सर एग्जाम का क्वेश्चन सेट आप कर रहे हो ना?
नहीं, मैं नहीं कर रहा, ये कभी मैं नहीं करता।
सर थोड़ा बहुत बता सकते हैं क्या आएगा?
जो मर्ड सॉर्ट तक जितना किया है वही आएगा।
अब बहुत ज्यादा हो गया है टॉपिक।
अब तो होगा ही धीरे धीरे। अब नेक्स्ट टॉपिक क्यू आएगा, उसके बाद बैक ट्रैकिंग आएगा, बहुत आएगा और भी। डोंट वरी ऑन दैट।
अभी थोड़ा सा ऐसा लग रहा है कि सही नहीं है, कोडिंग इजी नहीं है।
अभी भाई कोडिंग एक दिन में नहीं होता।
नहीं
इस पे
बट पहले के जो लेक्चर्स थे ना, मतलब टेस्ट 1 के पहले तक
हम्म,
सब समझ में आ रहा था।
तो वो तो इजी से ही टफ में जाता है ना बस।
हाँ बट ये जब से रिकर्शन, टाइम कॉम्प्लेक्सिटी, स्टैक तो पहले भी पता था, बट टाइम कॉम्प्लेक्सिटी, ब्रूट फोर्स अप्रोच, ये वगैरह जो टॉपिक्स है ये थोड़े से डिफिकल्ट जा रहे हैं।
यस सर, मेरा तो और
एक्चुअल
ज्यादा
हो
difficult
क्या
जा
रहा
रहा
है वो नहीं समझ में आ रहा है।
क्यों? क्या प्रॉब्लम हुआ? स्पेंड
पता
किया
नहीं।
टाइम, वीडियो वापस देखा?
हाँ देखा, बट फिर भी वो मतलब फॉर लूप के अंदर फॉर लूप लग जाएगा, सब हो जाएगा, लेकिन टाइम कॉम्प्लेक्सिटी कैलकुलेट ही नहीं कर पा रहा अभी तक मैं। रिकर्शन पता है कि जो भी बड़ा एरे है उसको पार्ट में डिवाइड कर करके उसको रिटर्न करेगा करके, ये भी समझ गया, बट एक्चुअल अप्लाई कैसे करना है उसको उस टाइम पे वो लॉजिक ही नहीं बैठ पा रहा।
ये प्रैक्टिस से आएगा, ये प्रैक्टिस से आएगा कि तुमको बिगर प्रॉब्लम को इन टर्म्स ऑफ स्मॉलर प्रॉब्लम सोचना पड़ेगा। पीएमआई पढ़ा है ना, प्रिंसिपल ऑफ मैथमेटिकल इंडक्शन?
हाँ
उस प्रिंसिपल को अप्लाई करो, तभी जाके आसान बनेगा ये।
देखना पड़ेगा थोड़ा सा।
थिंक ऑन अ नॉट लोअर लेवल पे मत सोचना, थिंक ऑन अ ब्रॉडर लेवल। ओके, बड़ा प्रॉब्लम है, फर्स्ट स्टेप ऑफ प्रॉब्लम, उसको मैं कैसे स्मॉलर में डिवाइड करूं कि मेरा आंसर आ जाए, दैट्स ऑल।
सर कोई ट्रिक नहीं होगा?
ट्रिक तो नहीं है बॉस, पीएमआई सीखना पड़ेगा, प्रिंसिपल ऑफ मैथमेटिकल इंडक्शन। आता ही है
ये क्लियर है कि 3 अगर बनाना है तो उसका सबसे छोटा अप्रोच यही है कि 3 बार 1 को प्लस कर लो।
यस।
ये मैं भी समझ गया कि वो यही है रिकर्शन और ये सब, बट वो टाइम पे 111 याद नहीं आता और वो लॉजिक अप्लाई नहीं होता, बस
ये
ये
प्रैक्टिस से
दिक्कत
आता
जा रही
है, ये प्रैक्टिस से आता है। हम सभी बहुत देर में हुआ है रिकर्शन अप्लाई।
रिकर्शन क्या है वो समझ गया, ब्रूट फोर्स अप्रोच क्या है वो भी समझ गया, टाइम कॉम्प्लेक्सिटी क्या है, कैसे कैलकुलेट होता है ये समझ में आ गया, बट बिग ऑफ एन कैलकुलेट करने का बोल दो, मैंने सबका कॉम्प्लेक्सिटी निकाल लूंगा कि इसका इतना आ रहा है, इसका इतना आ रहा है। अब दोनों को मिक्स करके वो लास्ट टाइम को कॉम्प्लेक्सिटी वीग ऑफ एन के टर्म में निकालने का बोलो, नहीं बैठा। जब
ठीक है।
जब आपका वीग ऑफ एन आता है तो वहां हमारा वीग ऑफ एन स्क्वायर आ रहा है।
कुछ गलत कर रहे हो और क्या?
नहीं ना सर, लेकिन आप जो लास्ट का कैलकुलेशन करते हो ना, जैसे आप कभी निकाल देते हो n/2 माइनस n²/2, ऐसा n²/2 माइनस n/2, वहां आप उसको निगलेक्ट कर करके n² ला देते हो, वहां हमारा n ही आता है। बट ऊपर जो कैलकुलेशन किया था आपने कि ये फॉर लूप का इतना आएगा, ये फॉर लूप का इतना आएगा, वो सेम आता है।
अच्छा, तब देखना पड़ेगा क्या इशू हो रहा है डाउट क्लास में। टिल देयर एवरीथिंग इज क्लियर। टेल मी, अभी तक जो भी हमने डिस्कस किया कोई डाउट है वगैरह वगैरह?
जो था वो बोल दिया अभी।
ठीक है।
सर थोड़ा थोड़ा क्लियर होता है सब में।
हाँ, अभी थोड़ा सा स्टैक में थोड़ा और दिक्कत जा रहा है कि स्टैक में वो किस हिसाब से चल रहा है स्टैक, वो थोड़ा सा समझने में समय लगेगा। लेकिन स्टैक क्या है ये पता था, तो वो अब जैसे वो लिंक लिस्ट वगैरह आएगा ना, तो स्टैक का पोर्शन क्लियर हो जाएगा।
ओके।
सर मेरे लिए थोड़ा नया है, इसलिए थोड़ा बहुत समझने में सर वो
ठीक है, धीरे धीरे होगा। डाउट प्रैक्टिस करो, डाउट क्लासेस में आओ, पूछो क्या डाउट है, वहीं पे
डाउट
डिस्कस
क्लास भी
करेंगे।
आप ले रहे हैं क्या? नहीं, टीए सेशन, सॉरी, टीए सेशन तो अलग।
टीए सेशंस तो मैं नहीं देता।
यस सर, वो
स्टैक से नेक्स्ट तो क्यू होगा, नेक्स्ट डे क्यू होगा और फिर लिंक लिस्ट।
हाँ, एक टॉपिक आगे बढ़ेगा तो प्रीवियस टॉपिक क्लियर होता है।
क्यू होगा, फिर लिंक लिस्ट आएगा, लिंक लिस्ट के बाद ट्री स्टार्ट होगा तुम्हारा। ये थोड़ा ट्रिकी टॉपिक होगा बस। ट्रीज, देन बीएसटी। बीएसटी इज अ गुड टॉपिक।
अच्छा, दूसरा एक क्वेश्चन था मेरे को, इनहेरिटेंस हमने पढ़ा था। इनहेरिटेंस में आपने सिंगल इनहेरिटेंस, मल्टीपल इनहेरिटेंस
और
मल्टी लेवल तीन ही लिया। हाइब्रिड नहीं है क्या टॉपिक?
हाइब्रिड है, मतलब किसी दो को मिक्स कर दो वो हाइब्रिड बन जाएगा। मल्टी लेवल भी हो रहा है, मल्टीपल भी हो रहा है।
हाँ, क्योंकि
थियोरेटिकली मैं दिखा सकता हूँ, कोई फर्क नहीं पड़ेगा ज्यादा, यही बात है।
वो एक देखना था मुझे।
ओके चलो, और तो मेरे साथ ज्यादा वक्त तुम लोग को है नहीं यहाँ पे बिताना।
हाँ,
आखिरी
15 दिन
महीना आ
बचे।
गया। क्या
15-20 दिन बचे।
15 नहीं, 1 महीना ही बचा है लास्ट।
हाँ, तो सर इसके बाद फ्रंट एंड चालू होगा फिर।
फ्रंट एंड तुम लोग का स्टार्ट होगा फिर।
अरे यार, वो और दिमाग खराब। तो आपका तो HTML CSS तक था।
मैं तुम्हारे कोर्स सीएससी का इंस्ट्रक्टर हूँ, ठीक है।
तो
Not for
HTML
full stack.
CSS आपका नहीं है क्या?
नहीं, मेरा नहीं है, कोई और लेंगे वो।
तो ये फ्रंट एंड में आएगा ना HTML CSS तो?
फ्रंट एंड HTML CSS जावास्क्रिप्ट रिएक्ट 4।
जावास्क्रिप्ट का जे भी नहीं पता, HTML CSS पता है।
इसीलिए कहता हूँ जब फ्रंट एंड बैक एंड में जाओ, डीएसए प्रैक्टिस बिल्कुल मत छोड़ना, इंटरव्यू में प्रॉब्लम में आ जाओगे, ठीक है। रिएक्ट, इवन लर्निंग रिएक्ट विल बी अ डिफिकल्ट वन। स्टार्टिंग में जो भी सीख रहा है, रिएक्ट विल बी रियली डिफिकल्ट वन।
सर रिएक्ट बैकएंड है ना?
नहीं, रिएक्ट फ्रंट एंड का फ्रेमवर्क पे। नोड जेएस विल बी taught in your backend. नोड जेएस, DBMS, everything will be there. Okay.
अच्छा सर, जाने दीजिए, अभी नहीं पूछूंगा, बाद में पूछूंगा।
Okay, all the best for your exams tomorrow. अच्छा करो
कल
सब।
क्लास लोगे क्या?
नहीं, कल नहीं, परसों।
संडे सर, संडे तो बख्श दो।
यस सर।
एक काम करो, मेघा मैम को ये रिपोर्ट करना अगर नहीं आना है उस दिन तो।
हाँ सर, ऐसे ही हालत खराब रहती। मंडे से फ्राइडे तक बॉस वैसे ही बजाता है।
अच्छा, I report this to Megha madam if you don't want on Sunday any doubt classes.
या फिर मॉर्निंग सेक्शन रख लो।
मॉर्निंग में मैं फ्री नहीं रहता ना, मॉर्निंग में मैं नहीं आ पाऊंगा।
ओके, या फिर नहीं, कल का तो टेस्ट है। बाकी मतलब जनरली भी सैटरडे को आप छुट्टी दे रहे हैं क्या?
नहीं, जनरली नहीं है, कल टेस्ट है इसीलिए, वरना सैटरडेज ही होगा तुम्हारे।
ओके चलिए, ठीक है, मैनेज कर लेंगे, कोई दिक्कत नहीं।
ओके, गुड नाइट ऑल ऑफ यू।
गुड नाइट सर।
गुड नाइट।